Okay, another question that appears that has some students confused is the 23rd question, which is quite a bit like the 21st question. Here again, we've got a Poisson distribution, and we also are talking, so Poisson again is talking about the number of things per time. So in this case, the number of people per hour, so V could be Poisson. Then we're trying to change things to talk about how much time per person. So instead of people per hour, we've got hours per person. So it's sort of the inverse of a Poisson. So not counting the number of people, but now counting the amount of time, which of course is exponential. We do have to be careful, again, in this question, like in 21, to reparameterize our success rate in terms of what we're really interested in. Lambda has been given to us here, at least in some way, shape, or form, and that is people per hour. If I do 1 over this value, or take the reciprocal of this value, I will then get hours per people. However, this question goes along to talk about not terms of hours, but we want time in terms of minutes, not in hours. So how would you do this? You can reparameterize lambda by saying 60, because there are 60 minutes in an hour, times the original lambda will give me people per minute instead of people per hour. And therefore, 1 over 60 times the original lambda would give me minutes per person. And so when you're going through this question and you're really trying to target time in terms of minutes, then you should really be using a beta of 1 over 60 times the original lambda, which I have here as in terms of hours, which then, if I multiplied it by 60, would be converted into minutes. After doing this, then here really you're being asked for the expected value of your new reparameterized exponential distribution. And then you're being asked to find some of the probabilities. So here, I think this question becomes extremely like question 21, except for making sure that you have your new success rate in terms of minutes instead of in terms of hours. The only slight difference between this question and question 21 is part D, where it says 55, or some different number for you perhaps, of the time you have the arrival rate be at most how much time. So here, at most, of course, is the less than or equal to sign. So here, imagine that there is a number such that on the left hand, or the left, or the less than or equal to, or in other words, at most, the area on the left is whatever the value they've given you here. In my case, it's 0.55. So here, this value is 0.55. And so instead of using the p-exp command, which is when we have the value, we get the area. In D, we have the area, and we want the value. So instead of the p-exp command, we're going to use the q-exp command. Remember, of course, that the area you give the computer should always be the area on the left and not the area on the right. And then, of course, you will have to give it the proper success rate, which in this case would be 60 times the original lambda given, because we want this answer to be in terms of minutes and not in terms of hours.